All right, welcome everyone. We are going to be doing formula writing this week again. So we're going to be writing formula now for polyatomic ions. So I'm going to put the polyatomic ions on board. Somebody's asking me where do they find the recording. They are on YouTube. I'll share that after. Just pay attention. I'm sure you're going to grasp it. All right, so let's go. We have hydroxide. This is nitrate. This is carbonate. There are way more, but I'm going to zero in on these for right now. We have sulfate. We have hydroxide is the first one. Nitrate ion is the second one. Carbonate is CO3 2 minus. We have sulfate, which is SO4. I'm just muting some people. Please mute. All right, so we have sulfates, we have hydrogen carbonates, phosphates, and yeah, we'll just work with these for now as we practice. So when you write the formula for polyatomic ion, and we have ammonium, which is a cation. All right, now the difference between the formula writing we're going to do today and the one we did last week is that when we use more than one polyatomic ion, we must bracket it. So if we use more than one polyatomic ion, we need to bracket that. So we have zinc, nitrate. Zinc is Zn 2 plus, and nitrate is NO3 minus. Based on the system I said we were to use last week, what's the next step? What's the next step? Nobody? So we write back the sign of the ion without the plus or the minus sign. And then we're going to go ahead and swap. So the 2 here from zinc will tell us that we need 2 nitrate. And the 1 from the nitrate at the top goes here, so it's 1 zinc. So the formula is Zn, and the 2 goes here, suggests that it's 2 nitrate. Nitrate is polyatomic, so we will have to bracket that. So it's ZnO3, close bracket 2. Let's go again. So we have Zn, open bracket. Somebody's asking, what are we doing? We are doing formula writing for polyatomic ions. Now, polyatomic ions are made up of more than one atom. So we have hydroxide, which is made up of OH, and the charge on the ion is OH minus. We have nitrate, which is NO3 minus. We have CO3 2 minus. Somebody can share the link to the YouTube for me, please, in the chat. All right, so this is the formula, zinc nitrate, right? So that's the formula right there, zinc nitrate. Zn, open bracket NO3, close bracket 2. This 2 means that we have 2 nitrate. That's clear?
Yes, miss.
All right, so we look on the most common error that a lot of students make is the hydroxide. The hydroxide is problematic because they're not seeing a number after the H, they assume it's one element. Hydroxide is also a polyatomic ion. So we're going to write calcium hydroxide. So calcium is Ca2 plus, hydroxide is OH minus. So we write the formula by writing the formula for the ions. The formula for the calcium ion is Ca2 plus. The formula for the hydroxide ion is OH minus. Then we are going to rewrite the formula using 2. What I'm doing is rewriting the formula without the plus or the minus sign. So we write the formula of the ion without the plus or the minus sign, OH1. So I swap the valency. So when I swap the valency, calcium, the 2 from calcium go after the hydroxide, and the 1 from the hydroxide goes after calcium. So it's Ca1. I don't write the 1. And the 2 there means I have 2 hydroxide. So in order to show I have 2 polyatomic ion, I'm going to go ahead and bracket the hydroxide. That's clear?
Yes, miss.
Yes, ma'am.
Yes, miss.
Yes, yes.
All right, so we have iron 3, and we're going to use phosphate. Iron 3 is Fe3 plus, and we have phosphate ion, which is PO4 3 minus. So Fe3 PO4 3. I'm writing back the formula without the plus or the minus sign, and then I swap 3 3. Both of them are 3, so I'm going to divide both by the same number, which is 3. So it's 1 of each. Remember last week I said once they have the same charge or they have the same valency, we use 1 of each atom. So here, phosphate is a polyatomic ion. But when we divide 3 by 3, how many phosphate ions do we now have?
1.
1.
1. So it's Fe P. Nate, please do not write on the board. FePO4. We are not bracketing, no bracket, because it's only 1. So it's only 1 PO4, so we do not bracket. Is that clear? It's 1 PO4,
Yes,
so
miss.
we do not bracket. All right. So I'm going to do another one. We're going to do ammonium sulfate. What's the charge and what's the formula? When they ask you for the formula, you have to give the symbol and the charge. What's the formula for the ammonium ion?
NH4 plus or
NH4 at the bottom plus at the top. Good. What's the charge on the phosphate ion?
2 minus.
Give me the formula. Remember when you give me the formula. Give me the formula. Sorry. So give me everything.
SO4 2 minus.
SO4 2 minus. Then we rewrite NH4 1 SO4 2. Swap the charge. So it's now 2 ammonium ion. I cannot write NH4 2. That means I have 42 hydrogen. That's not true. What do I do with the ammonium? What will I do with the ammonium? So I'm going to bracket the ammonium. So the formula is NH4 at the bottom here 2 ammonium SO4. Is this clear?
Yes, miss.
Why didn't I bracket the SO4?
Because it's more than one.
Only one.
It's
More
only
than
one. Okay. So we're going to do calcium carbonate. What's the formula for the calcium ion? What's the formula for the calcium ion?
Ca2 plus.
Ca2 plus. Hi, Abigail. Just remember to never call you Abby.
Hi, miss.
All right. So we have calcium, Ca2 plus, and what's the formula for the carbonate ion?
CO2 negative and the 3 yeah.
So it's CO3, 2 minus. What do I do now? I write Ca2, and then I write CO3. 2. Both of them have the same valency, so it's one of each. Or we can continue to put the 2 there, 2 there. 2 can be divided by both numbers, so it's one of each. So what's the formula for calcium carbonate?
CaCO3.
All right, good. Are we ready to do some on our own?
Yes, miss.
Okay, we are so ready. So let's go. I cannot see anything. So if you need to talk to me, once I start sharing my screen outside of Zoom, I cannot see the chat. So you'll have to let me know what's happening over there. So I go to my drive. Mm-hmm. Where is it? 1 minute. We was this document yesterday. Somebody asked me to share the handouts, but I did not. So I need to share this evening. Mm-hmm. All right, so you're going to be doing these are the ions this is what I gave last week. Let me edit this. Realize yesterday that the iron 3 is not there. So if you don't have this, you can just take a quick screenshot. This is iron 3. And then what I have done is I have placed the polyatomic ion in bold. So I bold that. So we're able to see that. So this is the chart we have here. So you can grab a screenshot. And then I'm gonna ask you to write the formula quickly for these 3, 6, 10, 11. For these 11 compound, you're going to quickly write the formula for these 11 compound.
Miss,
Yes.
is it necessary that we need to memorize them components selected?
Yeah, you must be able to write it. They can ask you for any compound.
Hey, can I take a screenshot first?
You want a screenshot of up here? Let me know when you grab it. Let me extend the table so the names show properly. 1 minute. Just fix the name so we can fix. This is if you don't know the formula, you're going to have problem when you get to formula writing. When you get to equation writing, and that's where a lot of students fail chemistry.
Excuse me, miss, can I get a screenshot of the questions to do while you're doing that? Oh.
Yeah. So this is where a lot of students fail chemistry.
Can you go back down again, please?
I stay down right now. It's on the way wrong. CH3. Let's go this. We're not going to use ethanol until we get to organic. So that's fine. All right, these are the formulas. Ready?
No, miss, not so quick.
Almost.
I feel like two of them repeat. Yeah. All right, I want to send the handouts I'm going to be using for today's class in the WhatsApp. You'll be able to view but not edit. Let me fix that. Share and export. Share. Manage access. Manage access. Everyone is in the WhatsApp group?
No, miss.
No, miss.
All right.
No.
I'm gonna try to see if I can fix this today. I have my phone. I don't want to switch because if I switch, then I won't be able to share the free Sunday invite copy. Sharing the WhatsApp formula writing. Yes. All right, so that's the link for the group. All right. All right, so that's the link for the WhatsApp. I'll send that to the chat.
Hello, good evening, Miss Gardner.
Good evening.
New here. New. I just tried to click. I clicked the link that you sent in the chat for your WhatsApp group, but as I clicked on it, it said failed.
No, anybody else? No, quite a few people joined a while ago, like a whole lot.
And I clicked on it and it said failed to get in for us.
Give me a number. If you don't mind. We can't go to the chat because I'm showing them the screen.
Excuse me, miss. Can you please add my number? Excuse me, miss. Miss, when I was joining the WhatsApp group, it said that it's failed.
Why? How much we in the group? What the maximum we can have? We have 95 people. Sure. All right, let me post something else. Let me post the link I was using last week to collect the data. I'm gonna send out an email, you know. Let me post that and yeah. I'm post something else. No, right of you. Drive. But people use the link, man. Where are we? We're almost finished because I want to do formula writing, you know.
Yes, it's almost done.
I want to do equation writing. Sorry. Um, forever. I'm posting somewhere else. You probably need to email it, the link to yourself. Those who have an issue with the phone, and see if that works. Where am I now? Oh, I need to join the WhatsApp group. So we have 97 people now. Isn't that good? All right, ready? I'm like, can somebody give me a quick update on what we should be doing? So writing the formula for the compounds that's on the board. That's what we're doing. Yeah. All right, ready?
Miss, it stops at J.
Iron 3 chloride is also there. So try that link at the bottom of the somewhere along there's a link to join the WhatsApp group also. Because I'm not sure what's happening. All right, ready?
Yes, miss.
All right, so I'm going to just screenshot this. So sodium chloride. What's the formula for sodium chloride?
NaCl.
NaCl.
Good. Then we have magnesium oxide.
MgO.
MgO.
All right. Aluminum nitride.
AlN.
AlN.
Then we have ammonium chloride.
NaCl.
Then we have lithium nitrate.
LiNO3.
Then we have calcium carbonate.
CaCO3.
Yes.
Then we have nitrate.
AlNO3.
Bracket 3.
Al open bracket NO3 close bracket 3. So remember, nitrate is a polyatomic ion. See it right here, NO3 minus. So Al is 3 plus nitrate is NO3 minus. So if I swap the valency, it's gonna be 3 nitrate, 1 aluminum. So this is the formula for aluminum nitrate. Clear?
Yes,
Excuse me, miss.
Yes, go ahead.
Wouldn't magnesium oxide be 2MgO since oxygen is a diatomic element?
But magnesium is also diatomic. So remember we said once they have the same chart. No, diatomic element when it's in a compound is the oxide ion. So it's O2 minus. No. We'll look on that shortly when we start writing equation. All right, ready?
Yes,
So
miss.
it's Mg2, the oxide ion is 2 minus, O2 and the swap. Both of them are 2, so we're going to divide 2 by 2.
Yes.
Each of them by 2, so we get MgO. Clear? Is there any you want me to do over?
Miss, won't the calcium carbonate be Ca bracket CO3 equals bracket 2?
No, calcium is 2, carbonate is 2. So when the charge is the same like calcium and oxide, here it's one of each atom.
Okay,
So I'll
miss.
do that one. No worries, I'll do it. So calcium is Ca2 plus, carbonate CO3 2 minus, Ca2, CO3 2,
Excuse
swap
me,
2, 2, yes.
is it okay if I wrote like for number 4, I wrote brackets, NH4, close bracket, Cl, like, will C-sec
No,
accept that still?
you shouldn't beat it because it's only one ion. So remember, when it's one polyatomic ion, we don't use a bracket.
Okay.
So you're clear why it's called CaCO3 now?
Yes, miss.
All right, so let's go. Ammonium sulfate. What's that one?
NH
NH4 bracket
bracket
2
2.
So open bracket NH4, close bracket 2, SO4. Do we bracket the SO4?
no
No.
miss.
Why?
Because it's just one.
Good. Iron 2 hydroxide.
FeOH2.
Open bracket
Open
OH2.
bracket. Oh yeah. Oh my.
Remember, I tell you this is the trick one, so let's not let that trick us. And then we have zinc carbonate, which is ZnCO3. And then the last one, iron 3 chloride, FeCl3. Would we bracket the Cl?
No miss.
Because it's
No,
not a
miss.
polyatomic ion. Clear?
Yes, miss.
All right, no worries. All right, so we can move on.
Wait, miss, question.
Sure.
For the carbonate, isn't it CO3 2?
2 minus.
So mean, so come for the calcium carbonate, you have CaCO2.
No, CaCO3. This is a
Oh.
3. Sorry, it's a 3. All right, ready? All right, so I did promise to do this, but I didn't do it. So let me go start out my screen like that. So firstly, it's gonna be a lot of writing today, right? You don't like write in the wrong place. All right, so on to the formula writing today. The first thing you need to know is the acids. That's the first thing you need to know. It's not really the first, but the popular equations are generally acids. We'll do some nitrates, we'll do some hydroxide. We're going to do those the last week of class, because I say I might do. I'm not sure, but we're going to multiple equation, but this is where we need to start first. A lot of students have issues with the solubility rule, right? And we're going to go through that because we're going to write equation and we're going to get full 3 marks for our equations. So your equation is generally marked out of 2. So when you mark 60, when I get the mark scheme will be red, all formulas correct, 1 mark. Balance, 1 mark, state symbol, 1 mark, right? Now, any of your formulas incorrect, you get 0. So even if your state symbols are correct, you get 0. Once any formula is off in your equation, when we're marking the exam, you get 0. 0. There's no going around it. So you can write the equation and make 1 stupid mistake and you get 0. So we're not doing that. So we master it. We're going to do really well in our exam. So here we go. We have acids. Our acids are hydrochloric acid, and the formula for hydrochloric acid is HCl, and our hydrochloric acid form chloride salt. So if you want to make a chloride salt, you can make a chloride salt by reacting some compound with hydrochloric acid. Now we need to know the solubility of our hydroxide. Now all hydroxides are all chlorides bromides and iodides, these are elements in group 7. They are all soluble except silver and lead. So what does this mean? Sodium chloride is soluble. Iron chloride, soluble, right? Aluminum chloride, soluble. Lead chloride is insoluble. Lead bromide, insoluble. Lead iodide, insoluble. Silver chloride, insoluble. Silver bromide, insoluble. Silver iodide, insoluble. That's clear?
Yes, Miss.
Yes, Miss.
Now we have sulfuric acid. Sulfuric acid is H2SO4 and it's minus sign. Oh, me get minus up here. So let me be a good girl and do what me say me I gotta do. Then keep my word. All right, let me share the WhatsApp. Let me share the link in the WhatsApp group. Give me a quick minute. Here, export, copy link. So I'm sharing this. All right, so we should have that in the WhatsApp group. Ready? We have sulfuric acid, H2PO4. What may I do? Sulfuric acid is H2SO4, sorry. And sulfuric acid forms sulfate salt, and it's SO4 2 minus. All sulfate salts are soluble except lead and barium. Calcium sulfate is sparingly soluble. Nitric acid is HNO3 and it forms nitrate salts. All nitrate salts are soluble. So every single cation that we bond with nitrate, those are soluble. Lead nitrate soluble, zinc nitrate soluble, copper nitrate soluble, ammonium nitrate soluble, lithium nitrate soluble. Clear?
Kinda. Yes,
So
Miss.
any cation, any nitrates you have, the rule says all nitrates are soluble. So every nitrate salt that you have, that salt will be able to dissolve in water. So it is soluble, right? So regardless of whether it is lithium, ammonium, potassium, sodium, lithium, calcium, zinc, barium, all of these nitrate salts are going to be soluble. So we have phosphoric acid, which is H3PO4. Phosphoric acid forms phosphate salt, and the formula for phosphate salts is PO4 3 minus, and all phosphates are insoluble except sodium, potassium, and ammonium. Carbonates, H2CO3 forms carbonate salt, and all carbonates are insoluble except sodium, potassium, and ammonium. So you realize all the salts that are insoluble, all of them are insoluble except sodium, potassium, and ammonium, right? Then we have hydroxides are insoluble except sodium, potassium, ammonium, and calcium is sparingly soluble. Put in some water. No, all salts of sodium, potassium, and ammonium are soluble. All salts of sodium, ammonium, potassium, all of those are soluble. So let's go. When we write an equation, we need to describe the state that each substance is in, whether they are reactants or products, right? No, we have to use the state symbol. We use S is used, so we use S for metal, metal oxide, and insoluble salt. So if a salt is insoluble, example, silver bromide, silver iodide, silver chloride, lead bromide, lead iodide, lead chloride, we use S. Calcium, barium sulfate, lead sulfate are insoluble, so we're going to use S. We can't use S for nitrates, really, because they're soluble, only if we're doing decomposition reaction, and we'll look on that, I think, the last week of class. So once a salt is insoluble, we're going to use S as its state symbol. If the substance is a metal, we're going to use S as its state symbol. And if it's a metal oxide, we're going to use S as its state symbol. Are we clear when we use an S?
Yes, miss.
Yes,
Miss,
miss.
can you
No.
like re-step back? Because I just go by like a few steps. Well, a couple more steps.
What do you mean? Say again. Not following what you're saying.
Miss, what were you talking about? The Aquarius?
Aqueous.
Aquarius?
We don't reach
Because,
there, say it.
Miss, I'm not sure where we are right now.
We were at solids and we said we explain when we use S. Solid means we use when a substance is solid, we use the symbol open bracket S, close bracket, and we say that for all metals we use S, except mercury. Metal oxide we use S, and for insoluble salts, so if you have a salt that is not able to dissolve in water, so over here where it says all chlorides are soluble except silver and lead, silver chloride, silver bromide, silver iodide, we would use an S for it because the salt is insoluble, so it's a solid. Lead chloride, lead bromide, lead iodide, we would use solid. Barium sulfate is not soluble. Lead sulfate is not soluble. So if we write those in equation, we have to use an S. All nitrates are soluble, so generally going to not use S for nitrates unless we're looking at decomposition reaction. So every phosphate, so lead, zinc, barium, iron 2, iron 3, copper phosphate, those are insoluble, so we'd use an S for those substances. All carbonates, so for example, calcium carbonate, iron 2 carbonate, iron 3 carbonate, lead carbonate, magnesium carbonate, those carbonates are insoluble. So if we have them in an equation, we are going to use the symbol S. So we're finished with S. Are we clear when we use S?
Yes, miss.
Yes, miss.
So the next state symbol we have is AQ, and AQ is for aqueous. This means this substance is soluble in water. So any substance which is soluble in water, we use the symbol AQ. Any substance soluble in water, we use the symbol AQ. So when do we use this? We use it for all acids. Once we have an acid in the equation, we are going to use AQ. If a salt is soluble, we are going to use the state symbol AQ. So for example, hydrochloric acid, I will use AQ. Zinc nitrate is soluble, so I use AQ. Sodium chloride is soluble, so I use AQ. Sodium hydroxide is a soluble substance, I use AQ. Ammonium phosphate is soluble, so I will use AQ. The next state symbol is liquid. We use liquid for water, bromine. Bromine is a liquid unless we're using aqueous bromine, but bromine is generally a liquid. Mercury is also a liquid. Mercury is a metal, but it's the only metal that's not a solid. So if we have mercury, popular multiple choice question, mercury is a liquid, as well as molten or melted ionic compound. So when you get to electrolysis, for those who have done it or those who have not done it yet, you're going to come across a lot of molten or liquid ionic electrolytes. You have to use the state symbol L for those. Lastly, gas. we use gas for carbon dioxide, oxygen, hydrogen, nitrogen dioxide, water vapor is a gas, chlorine is also a gas. So that's when we use state symbol. Every time I write the formula, I will readdress this and we are going to use the state symbol. No, writing balance equation, and this is what we're going to be doing. So you're going to state an equation in Word. So you're going to have a word equation. We will use word equation for the beginning, and then later on it's going to become automatic. We're just gonna get it. So we have word equation. So we start with a word equation. Then we are going to convert the word equation to chemical formula. So we just spent last week and the beginning of this class looking on word equation, where we have where we wrote chemical formulas. Sorry. So for example, a while ago we wrote calcium carbonate and we wrote it as CaCO3. That's the chemical formula of calcium carbonate, right? So every chemical written in Word, we have to convert that to a chemical formula, right? That's clear. So that is why we started with formula writing. So is part 2 clear?
Yes, Miss.
Yes, miss.
All right, good. In addition to part 2, what we need to understand, although the magnesium ion is Mg2+, although the calcium ion is Ca2+, although the iron is Fe2 or Fe3+, although zinc is Zinc2+, when we write, so let's read, metal exists as single entity. When a metal is uncombined, meaning there's nothing at all beside the metal, I'm saying magnesium reacts with, I'm saying zinc reacts with hydrochloric acid, zinc reacts with oxygen. If it's zinc only, we are going to write when metals are uncombined, write the formula of the metal atom only. So I don't write the charge and I don't put anything at the bottom. So magnesium is Mg, sodium is Na, calcium is Ca, iron is Fe, and lead is Pb. That's clear?
Yes, miss.
Yes.
For non-metals is a whole different story. Your non-metals generally exist as diatomic. So if I say hydrogen, you are not going to write H. What you're going to write, however, is H2. So the following substances are written as diatomic molecule: hydrogen, H2, oxygen, O2, fluorine, F2, nitrogen, N2, chlorine, Cl2, bromine, Br2, iodine, I2. So these non-metals are written as diatomic molecule. They do not exist by themselves. However, for the metals exist as single entity. So we're going to go back to the atomic notation. All right, let's go. Here we have, right, the atom is represented by the symbol A. X is the symbol of the element. A is the mass number, B is the atomic number, C is the charge, D is the number of entity, right? Let's look at the number of entity. So we're zeroing on D. D is the number of entity. When we look to the bottom right of a number, it tells us how many entities we have. When we look here, it says metal exists as single entity. So because they are single entity, to the right of the metals, I see no number. I just see Mg, Na, Ca, Fe, lead, Pb. Clear, there's no number there. However, these are diatomic. Di means two. So I will see a 2 where D is. To the bottom right, it tells me how many of each atoms I have. Is that clear?
Miss,
Mm. You said Miss, I waiting on you.
like how them atom, them single and them stand on them own and everything. Why them can't be one? Why them have to be two?
No, these are not single and they don't stand as their own. These are diatomic. Metals are stable because metals have metallic bonding. Non-metals are not stable, so they share electrons in order to become stable. So this is as a result of covalent bonding, but I'm not going over covalent bonding today. What I want you to appreciate is that the non-metal atoms do not stand by themselves. They are diatomic. That means it's two of them. So where the D is right here in the formula, XD, to the bottom of each of these, I am seeing a D, right? So hydrogen, H2, oxygen, O2, fluorine, F2. So it's two fluorine atoms sharing a pair of electrons that makes the fluorine molecule. These are diatomic molecule. Nitrogen shares three pair of electrons with another nitrogen atom in order to become stable. So because two nitrogen atoms are sharing, we have N2. Chlorine shares a pair of electron with chlorine, so it becomes Cl2. Br shares an electron with Br, so it becomes Br2. I shares an electron with I, so it becomes I2. Is that clear?
Yes, miss. That's the one confirm sound.
Good. So let's go again. We start with our word equation. We converting the word equation to chemical equation. So we use the system that we've learned last week and the beginning of this week to name them. Then we're saying if the metal is uncombined, all we write is the symbol of the metal only. We do not put in the charge and we do not put in any entity. So we don't write Mg2+, we do not write that. All we write is Mg. All we write is Na for sodium. If it says calcium, all we write is Ca. If it says iron, all we write is Fe. If it says copper, all we write is Cu. However, there are some metals that are diatomic. Your non-metals are diatomic, so we write them H2, O2, Cl2, Br2, F2, all of those. Somebody needs to mute. The next step is going to add state symbol. We already went through that, so I'm not going to go through that again. We are going to practice it. Then we need to balance the equation. When we balance the equation, we are listing the number of elements on both sides of the equation. I use a table. Some people actually write it out. Whatever you want to do, it doesn't matter. Then the next thing is we are going to balance the equation by putting numbers in front of each formula to increase the number of atoms in the formula. So let's go again. We're balancing the equation. We cannot change the formula. What we can do is put a whole number in front of the formula. When we put a whole number in front of the formula, what we will have is we will have the number of atoms in the compound increasing. So today we want to look on two types of equation. The first equation is what happens when metal combines with oxygen. So the first equation we're looking on is metal plus oxygen forms metal oxide. That's the first one we want to look on. So we're going to do that and then we come to the second one. All right, let's go. What we have here is we have, oh, we have a full 100. I was wondering if I was going to next week. I probably have to up the Zoom. Anybody trying to join won't be able to join because the Zoom room can only hold 100. All right, let's go. Here we are. share whiteboard. Let's go. So we have metal plus, when we react a metal plus oxygen, we form metal oxide. May I have a metal, please?
Miss Calcium.
Magnesium oxide.
Magnesium.
So we have calcium is a metal. So when I react calcium with oxygen, what is formed, this aromatic is produced. What is formed, what do I say is formed? Metal oxide. The metal in this situation is what?
Calcium. Oh, we did it right. No, that's not. Oh.
So I form calcium oxide. So step 1 says I have a word equation. I'm going to, step 2 says convert the word equation to chemical formula. Right here, I am seeing calcium. Is calcium reacting with anything there? When I see, is calcium bonded with anything right here?
Yes, Miss.
Right
The
here.
oxygen.
No, it's gonna bond with the oxygen, but right here, calcium exists
No, Miss, it
alone.
not.
So it's not, it doesn't have anything right there, it's just calcium. So what we said a while ago is when metal atoms are uncombined, they exist as single entity. So all we write is the symbol of the metal. What is the symbol of the calcium metal?
Ca.
A, capital C.
And we said that all metals are solid. So my state symbol here is going to be an S. Clear?
Yes, Miss.
Yes,
So we use S when it is metal, metal oxide, or an insoluble salt. Here we are using S because it is a metal. Now here, oxygen is there. Oxygen is diatomic. So what does it say? When I write oxygen, I write what?
2 at the bottom.
the bottom.
It's O2.
This-
Clear? And oxygen is a gas. So I go ahead and put O2 gas. Clear?
Hey, Mr. Me, is this going to be an equations?
No. Gas. We use gas for oxygen, hydrogen. Look back on the notes. Oxygen, hydrogen, water vapor, nitrogen. The list is there. So oxygen is a gas. Now we're going to write the formula for calcium oxide. Calcium is Ca2 plus. Oxygen is O2 minus. Is this clear?
Yes, Miss.
So I go ahead and I write Ca2. I go ahead and I write O2. Switch them. This becomes this. So I'm not in any rush to get the formula for calcium oxide. I am working it out because if I work it out, I will get it correct. What's my formula now for calcium oxide?
CaO.
Very good. Are we all clear on to how I got the CaO?
Yes, Miss.
Calcium oxide is a metal oxide. What is the state symbol for metal oxide?
AQ.
Metal oxides are solid. Metal oxides are solid. Is this clear?
Yes, Miss.
Wait, Miss, let me write it down.
All right.
It's insoluble because the oxide has to do with bases and all bases are insoluble, right?
No. We're not doing that. We're not
Oh.
doing. Let me tell you why we're not doing that. When I give you the equation, right, with sodium oxide, we are going to do that next two equations from now. You're going to be tempted to write Na2O as aqueous. We're not doing that. Once we have a metal oxide, once it has nothing to do with base, it's just a principle, because some bases are soluble. We're not studying it that way. Anytime you see a metal oxide in an equation, you must write the state symbol as S. Once it's a metal oxide, if it dissolves in water now, the product is different. But if you say sodium oxide plus water, sodium oxide is S. All metal oxides have the state symbol S. Now I'm going to go and I'm making a list of all the elements I have. So here, element. The elements I have is calcium and oxygen. Left, right. Clear?
Yes, miss.
Left mean on my reactant side, right is my product side. So my equation have reactant product on the left-hand side, are my reactants on the right-hand side are my products. Before I do anything else, I want to remind you of this notation that we have right here. The notation is X. What is it? XD, where D tells us the number of atoms that we have. Let's go. Look to the bottom right of calcium. Are we seeing any number there? No. Are we seeing any number to the bottom right of calcium?
No, miss.
So it means we have one calcium. Look to the bottom right of oxygen on the left-hand side. Are you seeing a number there?
Yes, miss.
What number is that? That number is 2. So that means I have 2 oxygen. Let's go again. Calcium to the bottom right of calcium, I see no number. That means I have 1 calcium. To the bottom right of oxygen on the left, I am seeing O2. 2 is there. So that means the number of oxygen that is in there is 2. Clear?
Yes, miss.
On my right-hand side of my equation, I see calcium. So I look to the bottom right. Am I seeing any number after CA?
No, miss.
No, miss.
So it is 1 calcium. I look to the bottom right of oxygen on the right-hand side. Am I seeing any number?
No, miss.
No.
So it is 1 oxygen. Is that clear?
Yes, miss.
All right, let's go. Now I need to make sure I have equal number of atoms on both sides of my equation. I do not worry about calcium because I'm seeing 1 and 1. That's balanced, right?
Yes, miss.
For oxygen, I see 2 on the left, but only 1 on the right. Are we all seeing that?
Yes, miss.
I'll give you a minute to make sure you have written off what I have on the board, because when I balance, I don't want people to be saying, what am I doing? For those who join late, what's happening in the documents I use as notes for today's class. That was the documents I use as notes for today's class.
Miss?
Yes.
Miss, so how come you saying for oxygen there's a 2 on the left, but I'm just seeing like a 2 little 2 right there on the right there at bottom right. Am I see
Because I'm putting the numbers in front. So it's a big
okay.
2 because I'm listing each number. So this is
Okay.
a table. Bottom right a calcium on the left hand side, no numbers, I write 1. Bottom right of oxygen on the left side. The 2 there means I have 2 oxygen. So I say on the left hand side I have 2 oxygen. On the right, I'm seeing no number after calcium and oxygen. So it means I have 1 oxygen, 1 calcium. Ready?
Thank you, Miss.
Everybody's ready for me to proceed?
Yes.
Yes, miss.
Yes, miss.
All right, listen to this. I look on oxygen. On my left, I have 2 of them. I have 2 of them. On the right, I have 1. I ask myself, which number multiplied by 1 gives me 2? What do I ask myself? Which number multiplied by this give me this? What number multiplied by 1 gives me 2?
2.
Miss 2.
Look where I put the 2. I put the 2 right here in front of the calcium oxide. Let's go again. I ask myself, I have 1 oxygen here, 2 over here. What number multiplied by this 1 oxygen gives me 2? My answer is 2, so I put the 2 in front of the calcium oxide. Is that clear?
Yes, miss.
Yes.
Yes, miss. Yes, miss.
This 2 will multiply by everything I have in the formula. So 2 times 1 calcium gives me 2. Clear?
Yes, miss.
2 times 1 oxygen gives me 2.
Miss.
Is that clear?
Yes, miss.
Yes,
So I
miss.
look into my table, I now have 2 calcium on my right. How much do I have on the left?
1. 1.
I
One.
ask myself, what number multiplied by 1 gives me 2? What number multiplied
2.
by 1 gives me 2? 2. So I go ahead and I put the 2 in front of the calcium. This 2 will multiply by the 1 calcium atom that is there. So now I have 2 calcium ion. So my balance equation is 2 Ca solid plus O2 gas produces 2 CaO solid. Is that clear?
Yes, miss.
Yes, miss.
All right. Ready? Can I move on?
Yes,
Yes,
miss.
miss. Yes, miss.
So earlier somebody gave me magnesium, so let's do that. Magnesium, remember last week I said once they're in the same group, they're going to react the same way. We're going to look at that. So I said once they're in the same group, they're going to react the same way. Let's look at that. Magnesium reacts with oxygen, and what is formed?
Magnesium oxide.
Magnesium oxide.
Magnesium oxide.
I don't use equal sign at all. I use an arrow. Need to make this smaller. All right, I can't get the magnesium oxide to hold there. So what I'm going to do, I need this to smaller. Can't make it smaller. So I'll write the oxide beneath it because the oxide belongs to the right hand side. So it's magnesium oxide. So let's go again. Magnesium is uncombined. What do I write?
Mg.
What do I write? Mg only, because
Mg.
magnesium is uncombined. Look up, Poppy, go outside. So what's the state symbol for magnesium?
AQ.
So magnesium is a metal. For metals, we use solid. Plus oxygen.
O2.
Oxygen is diatomic. I will write O2. Clear? No, magnesium oxide has magnesium 2 plus ion, oxide 2 minus ion. So Mg2, O2, swap, 2, 2, 1 magnesium, 1 O, MgO. Right?
Yes, miss.
Yes, miss.
What's the state symbol for metal oxides? Solid.
Solid.
Can we write that, please? Now I'm going to make a list of all the elements I have. Magnesium, oxygen. If you are learning and you find this class interesting, please remember I teach chemistry and physics online at the Online Science Academy. Chemistry is on Sunday at 6 to 8, right? I'm going over the syllabus. Also, the first Saturday in February, February 7th, I launch a brand new class, which is mole concept. So we're going to be doing mole concept for the month of February. So for the month of February, I'll be teaching mole concept, and in March, on Saturdays, I will be doing an organic chemistry class. Remember, you have to get mastery in organic chemistry to get a distinction in chemistry to get a grade 1, because organic chemistry is question 2 and number 5. So let me know if you're interested in the Saturday class. In the Sunday class, we are going over the syllabus. We are doing equation writing. So tonight we continue with some form of equation writing, and we're moving on to writing. What kind of equations we write tonight? So we're gonna react metal carbonates and acid, hydrogen carbonates and acid, and when we finish that, we're moving on to ionic equation. I don't think I'm gonna do ionic equation in this class because I want you to practice all types of equation here. So I'm not sure I'm going to get there. All right, ready. I'm going to make a list of the ions. Yes, that's correct, Brianna. On the left-hand side of magnesium, what number do I see there? No number. How much magnesium do I have? 1. On the left, on the right, sorry, on the right, bottom right of oxygen, what number do I have?
2.
On the right-hand side, what number am I seeing to the bottom right? No number. So it's 1 magnesium. How many oxygen do I have there?
1.
The class from 6. So if you want to come to the class, can text me at 353-73876-353-7322. I'll give you some information. I'll give you my banking information so you can sign up for the class. I do physics. I'm still at section A of the syllabus. Physics classes on Wednesday 6 to 8. Let's go. I will also have biology class on Mondays So if you're interested, you can let me know. All right, ready? Let's go. We have magnesium. Magnesium is balanced because I'm seeing one of each. Oxygen is not balanced. I'm seeing 2 here, 1 here. What number multiplied by this one gives 2? 2, but I put the 2 up here first. The 2 goes there and multiply by everything in the formula. So now I have 2 times 1 magnesium, 2. 2 times 1 oxygen is 2. Yes, I do physics class Wednesday 6 to 8. Doing Newton's law this week. Newton's law and momentum is 6 to 8:30 this week. So doing Newton's law and momentum this Wednesday. So we have 2 times 1. No, it's not a free class. Those are my paid class. I just want to help y'all out by giving us some free chemistry class. I'll text my number. I'll just send a message in the chat once I'm finished. So we have 2 times magnesium, 2 times 1 gives us 2 magnesium, 2 times 1 oxygen gives us 2. So now my magnesium is no longer balanced. Are we seeing that?
Yes, miss. I put it to equal to magnesium.
So what number multiplied by 1 gives me 2? I always ask that. See somebody type my number in the chat. So the answer there is 2. 2 times 1 gives me 2 magnesium. So my balanced equation reads 2 Mg solid plus O2 gas produces 2 Mg O solid. So I realize that the equation is the same thing as that for calcium, because calcium is in group 2, same group 2 metal reacting with oxygen. So the equation is 2 Ca solid plus 1 O2 gas produces 2 O2 solid. Clear? 2 Mg solid, 1 O2 gas, 2 MgO. It's the same because magnesium and calcium is in the same group of the periodic table. Group 2. Now I'm going to go ahead and react group 1. I'm going to react group 1 with oxygen. Give me a group 1 metal.
Sodium. Sodium oxide.
Sodium plus oxygen will form what?
Sodium oxide.
Clear? So it's $10,000, Brittany, for 1 class. If you're doing more than 1 class, it's $8,000 per month. All right, ready?
Miss, is this still going to be a solid?
Yes, which one?
Mr.
Yes.
Sodium oxygen, so sodium oxide. Is this going to be?
Yes, ma'am, because let's do the state symbol. Here I have sodium. What's the symbol for sodium? Na. What's the state symbol? Solid. Don't. Oxygen gas. O2 gas. No, miss. If I have a solid and I pass a gas over it, isn't it still going to be a solid? If I get my pencil and I blow over it, can I have a solution for me? No, I cannot.
Oh, you know,
That is why I said we are not using the principle of basis at all. We are using the fact that anytime I have a metal oxide in an equation, I must write S. It is solid.
I never thought of that being miss.
No, most students don't. That's a common error. So I've been teaching long enough to know all the errors my students make, and to fix them. So sodium is Na plus, oxide is 2 minus. So I have Na1 or 2. Remember, I'm not in the fast game. I am taking my time and I am working it out because I'm not getting it wrong. I know to write formula. I practice the formula writing technique. So my formula is Na2O. So I will write Na2O right here. Clear?
Yes,
My
Miss Clear.
metal oxides are solid. So I go right there, my love, and I put a solid.
So Miss, it was a solid and a liquid with the same result, right, Miss?
All right, you're way ahead of us. Ignore us, please. Everybody else ignore us. If I react this, you're gonna tell me that this is soluble, but it's a metal oxide. Metal oxides are soluble. So if I react it with water, it is soluble. It's not going to be sodium oxide soluble. It's going to be sodium hydroxide. And this is going to be aqueous, but the metal oxide is solid, so it don't matter. Once a metal oxide is in an equation, it is solid. So when they say it dissolve in water, when sodium dissolve in water, it forms an alkali. It doesn't form a metal oxide solution, it forms an alkali, which is a different compound. Do you understand, Miss? Because you're a little advanced than the rest of us.
Excuse me, Miss.
Go again.
So hypothetically asking, so would you like put like a 4 in front of sodium?
No, I don't know. You are rushing my class. Yes, but my students don't know. So you work with our pace. Let's go. So I know a lot of us know it, but I'm here for the child who, for the life of them, their teacher have been teaching them formula writing and they just cannot get it. I'm here for that student. So I'm going to take my time. I'm not going to rush. So forgive me. I am not in the business of rushing. So you may be right, but we are going to all arrive there. Everybody's gonna see how we balance it. Look to the bottom right of sodium. Are we seeing any number?
No, Miss.
So that means I'm gonna do acid. I have 20 minutes, 10 minutes leave. I'm gonna move on to acid shortly. So 1 sodium. How many oxygen?
2.
2.
Okay. On my right hand side, I'm not even gonna rush it now. We'll just do acid next to it. I'm not even in any rush. On my right hand side, how many sodiums do I have?
1.
Look to the bottom right of sodium. Are we seeing any number there on the right hand side,
2.
right here? So
No,
this
Miss.
2 means we have right hand side. Let's go. It's Na2. So the 2 here means I have 2 sodium. You see why I have to go slow? Because some people don't see it. Let's go. The Na2 there means how many sodiums I have.
2.
2.
And I have no number after oxygen, so I have 1 oxygen. Let's go. First thing we're going to balance in this equation is we're going to balance oxygen. So we're going to begin by balancing oxygen. Here I have 1 oxygen, over here I have 2. What number multiplied by 1 gives me 2?
2.
So I put 2 in front of the compound. Remember, that's what I've always been doing. When I put 2 in front of the compound, 2 will multiply by this 2 to give me how many sodiums?
4.
2 will multiply by this 1 oxygen to give me how many oxygen?
2.
So my oxygens are balanced. My sodium is 4. What number multiplied by 1 gives me 4?
4.
So I
4.
put 4 in front of the sodium ion elements. Sorry. So 4 times 1 sodium is 4. So my balance equation is 4Na solid plus O2 gas produces 2Na2O solid. Is this clear?
Yes, Miss.
So somebody said lithium. So I'm gonna go ahead and do lithium, and then I'll give you one more. I'll give you each one to do. So it's a lithium. Lithium plus oxygen forms lithium oxide. I'm not going to do the acid today. I'm going to ask you to memorize the table though for the acid with the formula, the name, their formula, types of salt form, and their solubility. We'll do the acid reactions next week. I'm not in any rush. Lithium, Li, solid. We use Li because nothing is there with lithium. Lithium is uncombined. Oxygen, O2 gas. Lithium oxide is Li 1, oxygen 2 minus. I write it without the plus or the minus. So this is 1, this is 2. So it's Li2O. So you realize it's the same formula like sodium and oxygen, right? Ready? We're going to practice every single type of equation. So if you join us, and I may extend it out extra week, I'm not sure. So somebody's asking what if it's longer. Even if it's longer, I'm going to teach you how to balance all equations. So I'm going to be doing acid reactions, going to be doing base reactions with you, and I'm going to be doing decomposition reactions with you. So you are going to get all, the only equation we're not going to be doing is combustion reaction because I'm not going into organic chemistry here. So I will balance those equations, so you should be good to go. All right, ready? Yes, ma'am.
You don't have any face-to-face classes, right?
No, miss, I live in a one bush. I live in Trelawney. Left, right.
Oh, okay.
Somebody asked that question. You can't answer the chat, you know. So you're asking, okay, so today's class will be simple equation being balanced. So today we're doing metal and oxides. We're supposed to do metal and acid, but I only have 10 minutes because I have a class to prepare for at 6. I have some homework to mark. So we're just doing metal and oxide today. That's what. So the topics of today's class should have been writing formula for polyatomic ions, as well as writing equations for metal and oxygen and metal and acid. I don't want to rush because I can rush it, but then you're not going to grasp it. I'm in the business of us balancing and learning correctly. So I'm going to stop right here. After this, I'll give you one equation, 2 equations for you to do by yourself. Where's the recording going to be posted? It's going to be posted on the Instagram site. Miss, where did you say the class from 6 to 8 was? That's on Zoom. Physics class is on Wednesday. All right, let's go. Left hand side, how many lithiums do I have? Everybody should on a screen now.
1.
Oxygen.
2.
1.
2.
Oxygen got 2.
Over on the right hand side, how many lithium?
2. 1.
So the IG is online Science Academy.
Means what about your YouTube?
And then the YouTube, I'm going to go on the YouTube channel shortly. Give me a minute. I'm soon showing on that. So I'm going to show you the YouTube after I do this one. So let's go. Lithium is 1 on the left. We have 2 on the right. One, we're not balancing the lithium first here. What do we balance first?
The oxygen.
Good. So here I have 1 oxygen. What number multiplied by 1 gives me 2?
2.
Where do I put the 2?
Before the arrow marks, like so.
Before the compound. So let's go. For the lithium oxide, 2 multiplied by 2 lithium oxide gives me how many lithium?
4.
4.
2 multiplied by 1 oxygen gives me how
4.
many oxygen? Oh, get
2.
2. All right, so my oxygens are balanced. My lithiums are not balanced. I have 4, I have 1. One number multiplied by 1
2.
gives 4.
4.
So I put 4 in front of lithium. So 4 goes here. 4 times 1 is 4. Clear?
Yes, Miss.
All right, ready. So my balance equation is 4 Li solid plus 2 plus O2, gas forms 2 Li 2 O2. All right, ready, your turn. No 2, solid. Solid, not 2, solid. What is wrong with me? All right, so your turn. But I promise to show you the YouTube channel. So let's go there. Hopefully I can find it. All right, so YouTube. Let's go. So it's learn CSEC Chem and Physics. So where is it? Right now, come up. I'll find it. Learn CSEC Chem and Phys. So this is it. Grateful for those who have subscribed. Oh, people watch your Redox video. That's very good. Share. Copy the link. So I'm gonna put the link here. Please subscribe. I'm gonna post wonderful things for us over there. Don't worry yourself. I'm going to work some passive questions to send them as well. So that's the link for the YouTube channel right there. Yeah. Where am I now? I am at this thing here. Zoom. Okay, back at Zoom. So this is your classwork. I'll wait. I'll give you 5 minutes extra. I'm going over time. So you're going to do potassium and oxygen. So you're going to figure out what is formed when potassium reacts with oxygen. What is formed when potassium reacts with oxygen, class?
Potassium oxide.
And you're going to barium and oxygen. So I'm hanging here around. All right. Anybody finish the first one?
Yes.
Mm-hmm. Ready? Did we get that?
Yes, miss.
Yes.
Yes.
Miss.
Oxide. BaO solid balancing. Alright, how was the session? You know, I like feedback. How was the session? How did we find today's session? For those who are your first class, how was it?
This was very educational. Right.
Very
So
educational. Okay. Good. I see somebody writes in the chat. You man, I can come and share. Anybody wants to share? How was the session? How was the session? Understandable. It was wonderful. What's the Instagram page? Online Science Academy. Easy to understand. Kimura says it was great. Melanie says it was great. Well, starting to me. Can you me spend 1 hour 40 minutes on Sunday? Hurry up, cook me write some piece to come to class. Great, informative. Anybody wants to come on and share? Hi, I'm Natalia, White Gardener over here. Yes, I'm the teacher of this session. Anybody don't want to talk? Okay. Thanks for coming. I'll see y'all next week. I'll post an assignment in the WhatsApp group for you to practice formula writing for this week. I'm going to send the Instagram page on the so it's Online Science Academy. I'm going to send the Instagram page. So I have another class at 6. I like how you explain. Thank you, Amina. I think that's the word. I think that's what your name is pronounced. Still not in the WhatsApp group? Send me a message. So my number is 876-353-7322. Send me a message on WhatsApp and I'll give you the link for the WhatsApp group. So ladies and gentlemen, thank you for joining me. I will see you next week at 4 p.m. where we'll do reactions of acid.
miss.
You can text, but I'm going to log off this so you can feel free to send me a WhatsApp. Bye.